All right, let's get started. Okay, cool. So as Chris introduced me before, I'm Thom Toogood, and I'm DevOps platform engineer based in Auckland. I'm doing this stuff for a little while, but today I'm really excited to introduce you to a new open source project, Spinkube. It's exciting for me because it sort of combines three really interesting topics that I've had for quite a while, which is serverless, Kubernetes, and WebAssembly. And hopefully by the end we'll demo it and you might have a chance to try it out yourself. But before we get into Spinkube, there are a few prerequisites. We sort of have to sort of give you up to speed with a few of the basics. But so WebAssembly, who's here has heard of WebAssembly? Yeah, it's pretty well known. So it's often abbreviated to WASM. So WebAssembly shortened. It is a bytecode instruction format that basically is a portable compilation target for programming languages. So basically you end up, you compile a programming language application, you end up with a bytecode, which is your WebAssembly, which is able to run as a client or server applications. So the main goal of WebAssembly was really to enable high performance applications on the web. Because your standard web languages are pretty slow, it really allowed you to create almost near native speeds and performance, and leveraging a lot of the new hardware that's available. But the great thing is that the developers or the designers, the people who came up with it just does not make any web-specific assumptions or provide any web-specific features. So whilst it's called WebAssembly, maybe they could have come up with a better name, but we've got that now. But it really allows you to not only run in the web, but pretty much we'll see anywhere, including Kubernetes. The other component that came out as well, it's often we refer to the same, is the WebAssembly System Interface, or WASI is their name. It's effectively a group of APIs that allow WASM applications to talk with each other, but allow a WASM application to also talk with the host. It just provides that standardization layer, and that way your compiled target doesn't need to understand essentially about things like networking, file storage, all that sort of stuff. It's really a way that interfaces and abstracts a lot of that out. Cool, just a really quick history, because I know this talk isn't about WebAssembly, but sort of give you an idea. It was started in 2015. There was a precursor to it, ASM.js, which was started with Mozilla. But in 2015, Mozilla went with the Chromium Edge WebKit developers and said, hey, let's create this new thing called WebAssembly. It was first released in 2017. And that's where browsers started supporting it. WASI was announced shortly after. That's when people were like, "Oh, this is quite cool," but it can run outside the browser, right? And and then in 2019 is when the W3C announced it as an official web standard, which is the fourth official language of the web. And most recently, just March this year, happened to be just before KubeCon over in Paris. We had the WASI Preview 2 was released along with Spinkube. And one of these things is you may not have heard of it, but you probably used it a lot because it's sort of the background of a lot of these really cool tools like Figma, Photoshop, Microsoft Office, and Google Earth. Allows them to add that that really feature-rich application functionality on the web. So there is another site you can actually look up, madewithwebassembly.com if you're interested. I don't know if it's been updated much, but it shows a few other examples. So the design goals, the WebAssembly design goals, which is what makes it really critical and why it becomes quite useful for non-web applications. It's super fast, so it's near native performance. There's no abstraction layers. It's sort of like you're running as low as possible. Super safe, so it's designed for the web. So you don't want code running from anywhere in the world to be able to access anything. So it runs fully sandboxed, and it's a deny by default configuration. So any code that's running just cannot do anything unless it's explicitly set. It's well defined. It's completely hardware independent, so it can be compiled on anything. Language independent, so you can potentially use any language you want. Sort of has to support it, but we'll get there. Platform independent, so you can run on anything, and it's completely open. Cool. So, I mean, if this does sound familiar, basically it is the latest generation of the write once, run anywhere. I mean, this is an old problem. There's been a lot of solutions in the past. So, this is just sort of latest iteration. There's a couple of things that make this interesting though, and I think it could be a winner. And that really does come with standardization. The fact that a whole bunch, a lot of the community and companies, vendors around the world have agreed on a standards approach. It may have a greater chance of success, but also it fosters innovation. So if you look at how browsers kind of work, browsers implement the standard, but they do it differently. There's a whole bunch of browsers. Kubernetes is sort of becoming the same way, where Kubernetes is essentially a standard, but there's a whole bunch of CNI networking plugins. They all circle around the similar standardization, but it creates that innovation. And then the big one is the language support. So quite often, in previous iterations, it's been very much language bound to a certain solution. So in terms of language support, and this is a big one. Currently, this is just the top 20 languages based on RedMonk's thing from a couple of years ago. So there's a whole lot more supported. But you can see the first line is essentially supporting WebAssembly 1.0. The second one is if there's at least one browser implementation. Third one is the WASM implementation, so that's at least preview 1. Sort of get to that, but not too important. And the last one, which is what we're talking today, is the Spin SDK, and that's if it's got a Spin SDK to be able to develop WebAssembly components with Spin. But there's a whole lot more languages. So if the one you're using isn't in there, it's most likely got somewhere along those lines. I can probably share some links if you're interested. The other thing that's happening at the moment is this is actually news to me until about a month ago, that there's actually a WASM CNCF landscape page, and that's growing very, very fast. So within Kubernetes, it is, this is growing super fast. And you'll see things like Spin, which we'll talk about today, is one of the application frameworks. But also, they've donated this, I think it's a proposed sandbox project that they're wanting to donate back to the CNCF. So these sort of two worlds are coming very closely together. So Spin, like I just mentioned, is we'll do a bit of a demo, but it is basically a really user-friendly developer tool for creating web microservices and web applications. There are a lot of other tooling out there, but this makes it really simple and really easy to get started. Cool. So with that all out of the way, I'll just quickly check the time. We're good. We can now get into what the really talk is about. So Spinkube. This is a open source project that streamlines developing and deploying WebAssembly workloads to Kubernetes, as it suggests. So it's really combining those two worlds of WebAssembly running on Kubernetes. It was a collaboration project by Microsoft, Liquid, Reply Liquid, SUSE, and Fermyon. And like I said earlier, it was released around March of this year, just before KubeCon. It is actually a set of 4 different projects. So it's the sort of the organization title or the project there. But within Spinkube, there's 4 separate repos. The first being the Spin operator. So the operator is installed into a cluster, and that's job is to manage and basically deploy your Spin applications inside the cluster and configure it in some respect. So containerd shim Spin is a project that basically integrates Containerd or reconfigures Containerd for running Spin applications. So you'll see that basically it looks, from a Kubernetes standpoint, looks like a standard pod running a container, but it's actually running a WASM application in a WASM runtime. Which leads us on to the runtime class manager. And this is another kind of operator that allows you to install WASM runtimes inside Kubernetes nodes. So when you're installing these applications, they're actually being installed as WASM binaries. They're not being run as containers, so to speak. And lastly is the Spinkube plugin, which makes it really super easy for converting those Spin applications that you create in Spin and deploying them to Kubernetes. So just quickly there, any questions, anything popping up at the moment? Yeah.
Kubernetes' whole ecosystem is around pods and containers, like network policy, etc. So if
Yep.
it's not based on containers and pods, then how is it like all other things in Kubernetes world?
Yep. Yeah, I can probably show you a bit around that in the demo. But this container shim Spin basically is an abstraction layer that allows, sort of from a Kubernetes standpoint, it still looks like a pod, still running. You can actually still use horizontal pod autoscalers. There's integration with Kida, which is application autoscaling. That all sort of works the same, but lower level, you're actually not running containers. And these binaries, which I'll show you, are super small, so you can actually get a lot more density and a lot more performance out of these sort of WASM modules or components than containers. But they can sit side by side, and for all intents and purposes, from a Kubernetes standpoint, it's a pod. It just happens not to be running a container. Yep. Cool. So quickly, a quick overview about Spin. So, like I said, it's the application tooling for. It was created by Fermion. It is being donated at the moment to the CNCF, or they're going through the Sandbox project. But it's a pretty simple workflow, quite familiar if you worked with application tooling before. You can run Spin new, and that will allow you to create a new sort of scaffold for your application. There's a whole bunch of templates, a whole bunch of languages. I can show you that in the demo in a bit. Basically, once you've got your app, you run Spin build. Build is kind of language dependent, depending on what the build process is. But the end result is essentially a WASM artifact. With Spin, you can actually run Spin up, which is really nice. So you can actually run that locally and test it out at that stage, and just do your development, anything you need to. But once you're happy with that, you can do the Spin registry push. And what that does is it actually packages up the WebAssembly artifact into a OCI image, and can push it to any OCI compliant image container registry, or image registry in this case, because it's not an image, so it can't be run like Docker, but it contains a binary instruction format inside there. Yeah, but you can still pull it and push like an image. And then once that's there, what you can get onto, this is the part of Spinkube, is the plugin, which you can run Spinkube scaffold, and that basically generates your Kubernetes YAML, your object, or your Spin app, and then you can obviously deploy that to your cluster. So going to the next one, you've got the Spin operator. So here's you're deploying that Spin app to your cluster, into the API server there. What the Spin app is a custom resource that the operator obviously knows about, and the operator is looking for these custom resources. This is kind of similar to a deployment object, kind of. There's a few extra bits and pieces because it's an application. But the Spin operator then takes the configuration of the app and goes and runs the deployment, and it does actually create services for you, and then deploys the actual Spin up to a node. So same sort of scheduling process that's sort of using Kubernetes underneath. And then when it's actually deploying, so the operator is deploying that application onto a node, this is where the magic happens. And you've got the runtime class manager, which basically its job is to configure the WASM runtimes on each node. And then again, the shim, as we talked about before. So this is basically an operator that can add and remove and change and version. It's a lifecycle manager for the shims. And then the shim itself is the sort of the interface between containerd and WASM, or the WASM runtime. And I think at this stage, I think with Spin they're using WASM time as the runtime. Yeah, and so so that means you've got the Spin app running inside your cluster, and that is, you know, you can scale that up or down. But these Spin apps are just basically single processes on a node. They're not a big chunky container, and you can really go nuts with the density depending on what the application is, of course. Cool. So you know, like I said, let's give it a whirl. Any questions before I jump into a bit of a demo?
Do spin apps need networking?
Yeah. Yeah.
And then container eShim does networking for them.
Correct. Yeah.
So it is
Yeah.
container from the
No. Good question. I'd probably have to check. Someone got dug right into that. But the shim is I think the shim handles the networking connection
so
to the process.
Since it has to it has to be compatible with CNI.
Yes.
If you replace different CNI and it still works, then that's a container from the point of view CNI. If CNI can manage it, then it's container.
No, containerd you can replace it.
It invokes CNI. It's not CNI on its own.
Yeah, I would have to check, but I can go into a demo and we can pull it up and look at the pod. I'm pretty sure that you do get networking in it. So just anyone else? Had it? Yeah.
Is there any minimum for CPU and memory for that, or is it running as a CRD?
In terms of running Spinkube, or what specifically?
If you deploy something, you have a limit and a request for
Yep.
CPU and
Yeah, so that's inside the Spin app. You can actually configure your resources, limits, requests, like you can in a...
you know what's the minimum for that? I mean, if I have 80% or 90% of the CPU of the node is already consumed, so can
Yep.
I install it, or there might be a pending?
I don't know the minimum. No, it'll probably be something you have to test. This is all relatively new, so I mean that's another bit of a caveat. It's in quite active development. I'll be honest, but it's quite exciting in terms of you know there's some great examples and a lot of action happening right now. But you know, Fermion, who are creating it, basically saying they're getting huge density gains from this in terms of over containers. But they're running a slightly different runtime, so this is more the open source version. But you know, yeah, but we can try it. So just to go through what I've done to set up this demo, I'm running just a local K3D cluster. It is configured with the container shim spin image, so I don't have to download and install it. Cert manager is a dependency of the spin operator, which is running inside the cluster. The runtime class is installed in there for spin, and the shim executor. And so what we can do, hopefully we can switch over. Cool, and just in here, just quickly show you. Woo. So we've got pods running in the cluster. You can see here is your spin operator, cert manager. If we go, get runtime class. We've got a WASM time spin runtime class sitting in there. And I don't know if we can look at anything else. So what we'll do is we'll work the workflow through from creating a spin app to deploying the spin app into the Kubernetes cluster. And hopefully we can dive in, and feel free to jump in and ask any questions, because we can probably have a look at how it works as we go. Cool, so if we go to 1, there we go. So the cluster's running in here, and we'll go apps, and we'll do a spin new. Cool. So running spin new gives me a whole bunch of templates. You can create your own templates. These are the built-in ones. Today we will go with just an HTTP Rust app. We can call this Auckland Cloud Native Meetup. Maybe make it a bit smaller. Cloud Native, there we go. We can add a description to the app. Let's just go defaults. A path, because this is the HTTP component, so you can set a specific path, or the default there is just it'll be listing on any path, and that's created. So if we cd into this, and we'll have a quick look at what that's created and some scaffolding code. Cool. So with Spin, it's created this TOML file, which really just describes the application. Don't really go into much detail, but we can see here there's a route, it's an HTTP route. You can see, sorry, we'll get out of that. We can see where the source, or where the actual build target will be. And so when we do a build, it'll run this command, which is a cargo build for Rust, and output our WASM binary, essentially to this address. So our Rust code, if we look in here, is pretty simple. We're just going to do the hello world, but we'll change this to hello Auckland. Yep, sweet. Make sure it's on there. And so this is really really simple Rust, and it's using the Spin SDK, which then this is leveraging WASI rather than having to define HTTP and things. This is just basically allowing us to just run a HTTP response. But we're also logging something here, handling a request in the header. So you'll see that there's actually some logging component as well. So that's super simple. I mean, I'm not going to do anything more because it might break. Cool. So let's do a Spin build. And I am on my... Cool. So this is running, like I said, running that Spin build configuration inside the config.yaml, building our application and using the WASM as a target. WASM 32, and hopefully that's going to be super fast.
Is this cluster running on your computer, or is it AKS as well?
So this here is running all locally, the Spin, and the build's running locally. So far I'm creating a new project local, haven't gone anywhere yet. So it's all just on my local machine. So what I can do, just quickly show you. So I can do a spin up, and just to show that how locally I'd be developing it. So if I wanted to change something, I can do an up build and a rebuild, and so I can see on this port here. You know what? Didn't save it. Yeah, there we go. Well, you can see how it works. Build. So that just rebuilt it. I didn't save that file, so I did the actual change and come through. So there you go. Hello Auckland. So that's how sort of the development workflow locally. You can see it's just an HTTP endpoint. It's spitting out what it needs to. There's a lot of better examples than this on the Spin, on the Fermion site under Spin. But yeah, we can go with that for now. So the next thing, if I go back here, we can have a quick look here. You can see the target's been created. Inside WASI and inside the release, there should be a Cloud Native WASM. And if we go show WebAssembly, yeah, so this is the actual resulting code, the sort of the WebAssembly binary format that we'll be deploying. So basically, any type of language will compile down to something like this. And that's how a WASM runtime or even a browser can read it, essentially.
It's good to me.
It's working?
Readable format.
Sweet. Fully readable format. But I'm sure there's a reverse, I don't know, ways to build. But so the next part of that flow was actually to do a registry push. And so this is actually now packaging up my application and sending it off to a image registry. So we do a Spin registry build, and we're going to use TTL sh AKL meetup. This TTL sh, has anyone heard of it? It's pretty cool for testing. So it's basically a fully anonymous container registry. So for any type of test builds or stuff, you can basically use any string here, and at the very end is how long you want to keep it for. So yeah, so for demo purposes, it's amazing. So no authentication, obviously. It's just anyone can grab the stuff. Industry not build push. Here we go. So what we're doing is it's packaging that WASM artifact into an OCI compliant image, and it's going to push it up to the registry server. There we go. And that's it there. So what we can do here, quickly, we can do a Docker manifest, inspect, have a quick look at what that created. Yep, cool. And you can see here, that is right here, about 1.9 meg. I mean, it's super small, you know, like, and yeah, in total, you know, it's under 2 meg in terms of this image size. So that becomes really important when you're deploying stuff and starting stuff up and you know, running it. It's super small.
Getting better, getting bigger over time, because the Docker images today are quite big compared to 5 years ago.
Yeah, well, I mean, it's just how much code, right? I mean, it comes down to how that, and it's the efficiency of your compiler. So I noticed, I'm not bagging on it, but Python is actually a lot bigger. Whatever your compiled object's just going to be a lot bigger. Rust is super small. JavaScript is obviously tiny. But yeah, it depends on the source, I guess. Yeah. Cool. So yeah, so that's the image. So if I go grab that image again, and we need to now invoke the Kube spin plugin. So if we go not spin Kube plugin. It's going to be from this image, and yeah, we'll just run that. Oh, Kube scaffold. Scaffold. Cool. So the standard output of this plugin command. So this doesn't come default with Spin. It's an add-on, a plugin to Spin as part of the Spinkube plugin, Spinkube project. But what we're doing here is we're outputting a YAML spin app object. You can see the kind. We're passing it the image, which is the WASM artifact, and we're saying replicas 2. So what I'll do is I'll actually just make that replicas 1, and we'll go and apply it to our K3D cluster. Apply. Cool, and now that's created. So if we do a get pods, we should see that that's creating. It should be pretty fast, and so now it's running. What I can do, I've got a bit of better. Has anyone heard of Lens or use Lens? Yep, cool. It's my old company, Mirantis, and we can see in here. We can just go. It's probably a better visual way to represent it. So if we go to the default namespace, we can see here it looks basically like a pod that is running. We can see it should have an IP. Yep, pod IP 10.42.2.6. The one thing that's different here is you can see the runtime class. So it's running a WASM spin v2. So rather than your standard container D container, it is an actual WebAssembly component. And you can see that basically that whole container shim will spin operator created the objects, and it's gone and deployed it off to a node. So if I go down here, I can show you quickly the runtime classes that's been installed, which is the WASM time spin, and the app executor we talked about before, which is the container D shim. So container D shim is that interface layer. So let's go and look at the services, because that's another thing that it automatically creates, and that's based on Spin being an HTTP function. It knows to go and create a service. And go to services, we should have Orca Meetup, and we can do a quick forward start, and we can open that up. Cool, and so that is now running on the Kubernetes cluster. We can jump back here when we can look at the pod logs. Should be able to see that in here. And we can see, so the pod logs are coming out here as we're hitting that server, hitting that particular WASM application. So it's for all intents and purposes, it looks like a pod running in Kubernetes, so it behaves that way. I'm sure you could probably write network policies to restrict access and do things. That should all just work. I mean, you don't have to worry about that. But to demonstrate, how quick it is, we can go back to the Spin app. Here, we'll go and quickly put this up to, let's say, 20 replicas. They close, and go and this will just go and create new replicas of that particular pod. And you'll see the startup times are just almost instant. I mean, it's just all it's doing is copying that 2 meg image. And it's all cached as well, so if it's already on the node, it's actually just pulling the cache and starting up a single process. So in terms of the scale up and scale down, it's pretty damn fast. And yeah, really, really efficient. So, it will just go up and down. Is there anything in here that anyone would be interested in looking at while we've got this running?
It's just a silly question.
Yep.
There's like 20 instances running that were already kind of running, waiting for it or something.
Yeah, so basically these are 20 little WASM processes essentially running on a runtime. So, and this is where there's a scale of efficiency because there's actually a runtime per node. And so these are processes running sandboxed inside that runtime. But they're very, very, very small. Like, I mean, the footprint of these are tiny. I mean, when you put it into a context of containers, it's magnets of scales smaller, and faster.
Basically, it's just making links
Yep.
to the main source and run like shadow.
Yeah, it's like a super small. You can see it's using a bit of memory, so but pretty tiny, and using a bit of CPU per process. So they're processes running in a sandbox inside the runtime, the WASM runtime. So I could probably, and this is my local machine, probably scale that up to 2,000. And I don't know where the breaking point would be, but I mean, you can actually scale it up because you don't have all of that overhead. So it's
Does this feature support OpenShift as well?
It should do. So it actually comes down to Containerd, the versioning at the moment.
And I guess Docker Swarm, it's out of scope for this service, right?
Docker Swarm.
Docker Swarm.
It's also my old company. So Docker Swarm's pretty much it's pretty much like Kubernetes under the hood. It totally depends on the version of Containerd today. It's pretty much the main compatibility issue. But most of the cloud providers, EKS, AKS, GKE, they all have support for Containerd, and that's to allow for that shim config to come in and swap out. That's their thing. But I'm sure over time, it's just an upgrade to Containerd to enable this functionality.
What if you have in AWS, for example, you have Kubernetes anywhere, so you can basically connect your on-prem to AWS. What happens if there is a difference between Containerd, between on-prem and in the cloud, and you want to run WebAssembly?
So I think, well, I mean, at the end of the day, I think it actually comes down to, and this is where the runtime configuration manager is super important around versioning. So one of the really cool things, and this is sort of blows my mind in terms of where WASI is going, is that you can have all of these different languages, and you can actually have multiple languages in a single WASM binary, right? And they have, with WASI, they have a single standard interface that they can talk to each other. But they both don't need to re-implement like the HTTP libraries of the language because they can offload that to WASM, or WASI, essentially. And so what that does is it throws, like the patching process of any patching to do with any HTTP layer is actually the runtime. It's no longer the actual application. So what not only makes the application smaller, it offloads and abstracts all of that security layer, so patching. So that would happen inside the runtime config manager because that's where a lot of the runtime or the patching would happen for WASM itself. Yeah, so it's pretty cool. And then this is where like Spin makes it really, really nice. So what we can do just while we're here, do I have time? Yeah, okay. We can do Spin add as an option. And what we can do is we can add, let's say, let's do Python. We can name it Py and description, but then this time we can do Py. And so if we could, what we've done is we've added a Python component. So the way Spin works is actually one of the first frameworks I've seen that implements the component model. And so inside our config.toml, spin.toml, you can see here we've got the original component, which is a Rust component, and now I've just created a new component in Python. And these can all be compiled into that same binary format and released. And effectively, the difference is the route you hit it on. So any route is going to be the Rust. The /py is going to be Python. So you could have like an API, a front end, built in different things, all compiled and delivered in the same sort of binary form.
Do you have PHP in there?
There is, yeah. Is it? Hang on.
So all the bad.
Oh, I think if I go.
Just execute it in your browser instead of.
Yeah. I don't know.
Make users pay.
There's a whole lot more like community templates. So these are just the ones that come built in. So I think there's a whole lot more, and you can add your own and create your own and things like that, which is kind of nice. But yeah, really cool how you can do that. There's also a whole bunch of other features that you can integrate with, like components, such as like a key value store, SQL. There's like AI inferencing, which at the moment allows, it's sort of a Fermion cloud only feature from what I understand, which basically allows you to sort of connect to a CPU and run a little language model externally, but integrate that back into your application to run it. There's lots of blog posts about that. I think that's going a bit too far for this particular talk, and I don't know if that would work with Spinkube today. So this is really about running WebAssembly inside Kubernetes, which is what we've demonstrated today. So if I'm looking at all of this here, just to make sure, I won't go through the process, but it'll be the similar thing: build, push, deploy. It's very similar. But if I jump back here and just look at the Spin app, inside the Spin app we can see this is where the definitions are. Like we said, the replicas, we can just drop that back to 1. It does support horizontal pod autoscaler by Kubernetes by default. So as soon as that one binary is using too much, it will add more, add less. It's super fast. The startup time is in milliseconds. Like once you've got that there, so that's been historically a problem with serverless inside Kubernetes, is your startup time of a container can be seconds. And so when you want to scale it up really quickly, you've got a huge lag. So this is milliseconds, and even single-digit milliseconds in terms of startup time. It's super fast. So to finish it off, I know we're probably running against the clock. Whoopsie, you go here. Finish it off. So yeah, what are the major benefits of Spin WebAssembly applications in Kubernetes? I think we talked about super small packages, like you're only building what you got. You don't have to manage all your container dependencies or OS dependencies like you do with Docker. So it really means that it's a lot smaller. They, like I said before, they start up almost immediately because there's not a container. It's running in near native speeds to the actual underlying node, so super fast. Completely sandboxed, and that's super important as well. It is deny by default, so none of these, even in that component that I showed you before, the Rust and Python, both of those are actually components running sandbox inside the WASM module itself. They cannot talk to each other either, so it's fully sandboxed. And you have to, sorry.
So Or if you want them to talk to each other.
Yeah, so that's where you use WASM, and you create your own custom interface, and then you can actually have them talk to each other. So, but you have to define that. So it's not assumed. Yeah, and explicitly allow it. So yeah, and super portable. So like we haven't shown it today, but you can easily go between running on ARM versus your x86 architectures. It doesn't care. It's the runtime that is handling that. The bytecode will run where it's allowed to run effectively. So yeah, so that is Spinkube. Hopefully, I mean, there's really good blog posts and instructions to get it running. Super easy if you just use K3D to have play with. And yeah, I mean, it's a pretty cool tool for deploying web applications, WebAssembly apps to Kubernetes. But questions, if there's any? Yep.
You had a slide on the landscapes near the start, and do you see this kind of replacing existing ecosystems or kind of creating new opportunities?
Yeah, I mean, yes. Some people say. I mean, that was I think a big topic at KubeCon recently. I think it's complementary at the moment. I mean, there's definitely not a one-to-one functionality with containers and Docker. I mean, if you're running a long-running process and doing a lot of things, the container model does work. You'll see here, this is more of an event-driven type approach. There's sort of limitations in some areas of the scale of what you'd want to run. There's just limitations in terms of what you can build and what the languages support today. So today is not a one-to-one relationship. But over time, I do see them coming closer together. I think it was 2019, actually, Solomon Hykes tweeted that basically if WASM and WASI existed in 2008, Docker probably wouldn't exist today. I think that was 5 years ago. I still think there's not that parity yet. So there's still a long way to go. The other thing is it's that standards. It's great that you have standards, but they take a long time to iron out and agree upon. And it'll be WebAssembly is turning 10 next year, and we're only sort of starting to scratch that surface. So yeah, hopefully one day I see that they're probably going to align, and they're probably going to somehow leverage each other.
Here's a good question.
Yep.
Will popularization of WASM make it impossible to do ad blocking?
I don't think so. That's kind of outside the box. Possibly because you don't have control of what's running inside the module.
The browser is a kernel.
Yeah.
And you don't have tags or anything. You don't have
Yeah.
access to
But I mean, it's so sandbox that even the module itself can't, by default, reach out and pull anything in. So you have to trust that source completely. So that source will have to be delivering those ads to you, sure.
Yeah.
But yeah.
And this is what they're all dreaming about. If I display a web page, I really don't want people to read advertisement from my web page, right? So AdBlock is trying to race against it, and eventually will hit the wall if they start executing ASM inside of our browsers.
Yeah, I haven't thought about that at all, but I guess there may be limitations. There may be a way that you'd want to be able to switch that off by default.
Window?
It could be. Yeah, you could create the new browser that just disables WASM by default. I don't know.
Oh no, it's not enough to disable WASM.
I know.
At this point you need to, I don't know what, do pixel recognition or something else.
Yeah, I couldn't tell you. But I mean, for years, obviously, the web worked with 3 languages, and now this is the 4th, essentially. So, but it's very feature-rich, as you say. So, I mean, there's a lot of complexity that you'd have to work around.
Yeah. How long since you tried to look into internet without a blocker? It's impossible.
Yeah, well, it's funny when you I use Brave quite a lot, and when you go to a browser without it, it's a different experience. That's for sure. Yeah.
That's coming.
Yeah. Okay.
Just for packaging apps and stuff like that, a lot of instances they're like minimum 10 gigabytes or whatever. It's like the smallest you can get, like E2 Micro or whatever.
Mhm.
Do you see people having their own kind of Kubernetes pods and stuff like that, or like multi-tenancy kind of deployments with other people?
I mean, at this stage, the way I see this is really handy is that you're wanting to get into WebAssembly. You probably have your own cluster, so like you're just sort of reusing existing infrastructure. I mean, if you were going just a WASM only road, there are, there's WASM Cloud, there's Fermion Cloud, there's a whole bunch of WASM Cloud hosts, and it may be an easier way in. But I see sort of this project allows you, if you're running Kubernetes, this sort of it's an add-on. You probably wouldn't set up Kubernetes just for this. I don't know, you might, but yeah. But
can you integrate with Docker and existing kind of Kubernetes stuff pretty well?
well, I mean, like I showed you before, it just looks, from a community standpoint, it just looks like a container running in the cluster. So anything that essentially that runs in Kubernetes can integrate as if it was a pod running in the cluster. So that makes it super handy. And I mean, if you were rebuilding stuff, you could rebuild it from a container model into a WASM model, and keep a lot of the same things if it was running inside the same cluster. So but like I said, it's early days, but it's definitely encouraging. And some of the things like the language support is it's a bit of a blocker. So obviously, the more people that get involved, the more demand there is. Hopefully, this thing's going to grow. Yeah. Cool. All right. Anything else? We good? Yeah. Cheers, sir. Yeah. And this last day, the top link there, spinkube.dev. That's the main project. It's got the quick start guide. K3D, super easy to run locally. But you can also just get started and running on your own cluster. Cool. All right. Cheers, guys.